Good morning. This is Alimun, Tirupati Institute of Engineering. Today we are going to discuss about the data warehouse models and the operators. So, what are the data models? There are the relational models, there are the star models, snowflakes, and then the cubes. And what operators we can perform on the data warehouse? So slice, dice, roll up, drill down, pivoting, and what is this multi-dimensional? So coming to this one, measures numerical data being tracked in the business can be analyzed and examined. So business parameters that can be defined a transaction relatively static data such as the reference tables. So analysts may want to view the sales data by geography, by time, and by product. These are all the dimensions. So the multi-dimensional data, sales by the product line over the 6 months, are the sales between the 1990s to 1991. That was a historical data we can mention. But multi-dimensional modeling coming to this one. Multi-dimensional modeling is a technique for structuring the data around the business concepts. Whereas models describes the entities and the relationships. Multi-dimensional models describes the measures and the dimensions. Dimensional dimensions are organized into the hierarchies, that is from days, weeks, quarters to years, right? So one more example is what is the product, what is the product line, and what is the brand. That is a product dimension has been organized into hierarchies such as the product line, and then so dimensions have the attributes such as the date, month, year, store ID, city, state, country, and then the base schema design. Most data warehouses use a star schema to represent the multi-dimensional model. Each dimension is represented by the dimension table that describes it. A fact table connects to all the dimensional tables with a multiple joins. Each tuple in the fact table consists of a pointer to each of the dimensional tables that provide its multi-dimensional coordinates and stores the measures for those coordinates. The links between the fact table in the center and the dimension table in the extremities form a shape like a star. A relational model with a one-to-many relationship between the dimensional table and the fact table. A single fact table with detail and summary data. Fact table primary key has only one key column per the dimension. Each dimension is a single table being highly denormalized. What are the benefits? It is easy to understand, initiative mapping between the business entities, easy to define the hierarchies. It reduces the number of physical joins, low maintenance, very simple meta. What are the drawbacks of the stack? Summary data in the fact table yields the poorer performance for the summary levels. Use dimension tables is the problem. Need for the accuracy. The sizes of the tables, time dimension 5 years to 365 days, store dimension 300 stores to reporting daily sales, product dimension 40,000 products in each store, about 4,000 cells in each store daily. Maximum number of base factor table records 2 billion record. A query involving one brand all the store, 1 year, retrieve, summarize over the 7 million fact table rows. Aggregating the fact tables. Aggregate the fact tables are summaries of the most granular data at higher levels along the dimension hierarchies. Next one is the snowflake schema. Snowflake schema is a type of the star schema, but a more complex model. Snowflaking is a method of normalizing the dimension tables in a star scheme. The normalization eliminates redundancy. The result is more complex queries and reduced query performance. The attributes with low cardinality in each original dimension table are removed to form separate tables. These new tables are linked back to the original dimensional table through artificial keys. What are the advantages of Snowflake schema? Small saving in a storage space. Normalized structures are easier to update and maintain. Coming to the disadvantage, schema-less initiative and end users are put off by the complexity. Next, ability to browse through the contents is difficult. Degrade the query performance because of additional joy. So, what is the best design? Snowflake schema. It is easier to maintain dimension tables when dimension tables are very large. It is not generally recommended in the data warehouse environment. Thus, coming to the star schema, it's more effective for the data cube browsing. Can affect the performance because it's having the less joins. Performance is the benchmarking can be used to determine what is the best design. Coming to this one, we can select either the snowflake schema or the star schema. So coming to the aggregates, operators are sum, count, max, min, median, average. So this aggregation or the roll-up operation aggregates summarizes the data to the next higher dimension element. So something like the total sales by the city year, it has been rolled up to the total sales by the region and then year. Navigation to detailed data, we go for the drill down. The selection defines a subcube. Slicing selection sizing gives a subcube. Sales where the city is equal to Gainesville and the date is equal to 115, 115, 11990. Calculation and ranking, visual operations, time functions. So, what are the query analysis? They are the query building, report writers, spreadsheet systems, web interfaces, and then the data